Myself Rupanjali Goswami. In our last video, we actually discussed how to find the solution of general solution of homogeneous linear differential equation with constant coefficient, and there actually we got that we have to find the auxiliary equation of the equation 4.23, where 4.23 is the homogeneous linear differential equation with constant coefficients. And here we got that we may have three possible cases. The first case was the roots of this auxiliary equation are real and distinct, and we already have discussed how to find general solution in that case. Now let us consider case 2. Today we discuss case 2. Case 2 is, let me write what is case 2. The roots of the auxiliary equation are real and repeated. So repeated real roots. So let us start with an example, then it will be easier for us to understand. So we start with an introductory example. Consider the equation y double prime minus 6y prime plus 9y is equal to 0. So call it equation 4.25. Let us write the auxiliary equation. The auxiliary equation of equation 4.25 is, just I have to write m in place of y, and when order of differentiation is 2, I have to write their power on m 2. Minus 6m plus 9 is equal to 0. We already have learned it. Now we factorize this, and definitely it is nothing but m minus 3 whole square is equal to 0. So the roots of this equation are say m1 is equal to 3, and if I call the other root as m2, then it is also 3. So we have seen that the roots are real and not distinct. Not distinct. Now corresponding to m1, the solution is e to the power m1x means e to the power thrice x, and corresponding to m2, because we have two values corresponding to m2, solution of the equation is e to the power 3x. So the linear combination of these two solutions is the linear combination. So what is linear combination? We have learned the linear combination of these two solutions is C1 e to the power 3x plus C2 e to the power 3x. Okay, of these two. But it is not the general solution. It is not general solution. My point is that it is not general solution for it is not a linear combination. It is not a linear combination of two linearly independent solutions. Of two linearly independent solutions. Indeed, we may write this solution in this form, because e to the power thrice x is there in both the two terms. So I can write it as c1 plus c2 e to the power 3x, And if I call C1 plus C2 as C naught, because C1 and C2 here are two arbitrary constants, so their sum is C naught, that is also an arbitrary constant. Okay, so it is not the general solution, because again I am repeating, this is not the general solution, not general solution. Why it is so? Because it is not the linear combination of two linearly independent solutions. And we have seen the equation which we have considered is a second order equation. It is a second order equation. And as it is a second order equation, we will get two linearly independent solutions by a previous proposition. So we are now getting only one solution of equation 4.25. As we already have learned to find the method of finding another one solution when one solution of a given linear differential equation, homogeneous linear differential equation, is known. Okay, so let us use that method. The method is actually the method of finding a solution of a linear homogeneous differential equation by reducing its order. So we shall use that by reducing its order when one solution is known. One of its solution is known. Okay, so let us use that method here to get the other linearly independent solution, because we have one solution, it is e to the power 3x. So we want another one solution of the same equation. For that, let us proceed this way. Let y equal to e to the power 3x into v, where v is to be determined, where v is a function of x, is a function of x to be determined. Okay, to be determined, we will determine it, we will find it. Now as we are assuming that this is a solution of that it is a solution of 4.25. So as it is a solution of 4.25 by our assumption, so if I differentiate both sides of it, then I will get y prime. This will imply y prime is equal to 3 e to the power 3x v plus 3 e to the power 3x v prime. And if I differentiate it again, that will give y double prime, and it is equal to e to the power 3x v double prime, where this prime, single prime stands for dv by dx and double prime stands for d2v by dx square. 6 e to the power 3x v prime plus 9 e to the power 3x v. So this is the expression for y double prime, and that is the expression for y prime. Now substituting these two, substituting into the equation 4.25. But what is 4.25? Let me write it, because it is above the screen. So let me write it: y double prime minus 6y prime plus 9y equal to 0. So let us put these two expressions, they are in that equation 4.25. Then you will see we get e to the power 3x. Let me show these two expressions: e to the power 3x v double prime plus 6 e to the power 3x v prime plus 9 e to the power 3x v, and this is y double prime. After that, minus 6 y prime is 3 e power 3x v plus e power 3x v prime plus 9y. But what is y? Y is e to the power 3x into v, which is equal to 0. So after simplification, you will get it. If I simplify it, then I will get that e to the power 3x v double prime equal to 0, because here I have 6 e to the power 3x v prime, here I have minus 6 e to the power 3x v prime, so they will get cancelled. Then here I have plus 9 e to the power 3x v, here I have minus 18 e to the power 3x v, plus 9 e to the power 3xv. So ultimately it will be also 0. So if I take v prime is equal to w, that means, or write just by writing dv by dx equal to w, then what will be v double prime? d2v by dx will be dv by dx. So I shall get e to the power 3x dw by dx equal to 0. But here, as we know that e to the power thrice x is always non-zero for every x, since e to the power thrice x is non-zero for every x. So for the product to be 0, I must have dw by dx equal to 0. For this product to be 0, this is 0, I must have dw by dx equal to 0. So this will give dw equal to 0. So integrating, we get w is equal to c. Now we choose c equal to 1. So in that method which we already have learned, we took we choose c equal to 1. So that we are doing here also. So choosing c equal to 1, we get w is equal to 1. But what is w? W is dv by dx. So it is equal to 1. This will give dv equal to dx. And as by integrating, I get v equal to x plus some c naught. C naught is an arbitrary constant. Now, what was our assumption? We assumed that y equal to v into e to the power thrice x is a solution of equation 4.25. So we have v was a function of x, e to the power 3x is equal to x plus c naught e to the power thrice x is a solution of the given second order equation of the equation 4.25. Then also we have from previous knowledge that this new solution and the earlier solution e to the power thrice x are linearly independent. So we choose these two linearly independent solutions will not contain any arbitrary constants. So we will choose c naught is equal to 0 because this contains an arbitrary constant. But we want this to be independent of any arbitrary constant. Therefore, we choose c naught equal to 0. Then we obtain y is equal to, this is our y is equal to x e to the power 3x. Now you can easily verify, and from previous knowledge we know that e to the power 3x and x e to the power 3x are linearly independent. And if you have any doubt, you can check yourself. Just you find the Wronskian of these two solutions, e to the power 3x and the x e to the power 3x, because the earlier solution we obtained was e to the power 3x and the new solution we are getting is x e to the power 3x. Now find the Wronskian, and it is just differentiate e to the power 3x, then you will get 3 e to the power 3x. Then differentiate x e to the power 3x, then it is our x e to the power 3x. So I will get 3x e to the power 3x plus e to the power 3x. Okay. So if I find its value, then it is e to the power 3x multiplied by 3x e to the power 3x plus e to the power 3x minus 3x e to the power 3x into 3x means 6x. So it will give 3x e to the power 6x plus e to the power 6x minus 3x e to the power 6x, which is equal to e to the power 6x, which is non-zero for every x. Okay. And therefore, we have seen the Wronskian of the two solutions e to the power 3x and x e to the power 3x is non-zero. Therefore, the solutions e to the power 3x and x e to the power 3x are linearly independent. Linearly independent. And actually, the method of reduction of order, by using the method of reduction of order, if we find a solution, provided one solution is known, the later solution and the earlier solution will be linearly independent. Okay, so the earlier solution was e to the power 3x, the later one we obtain is x e to the power 3x, they will be definitely linearly independent. Now the general solution, once you get the two linearly independent solutions, you can easily write the general solution. The general solution is y equal to c1 e to the power 3x plus c2 x e to the power 3x. And we can write it as c1 x c2 e to the power 3x. And don't forget to write what are these c1 and c2. These are arbitrary constants. Arbitrary constants. Okay. So actually the reason behind the writing the general solution in this form, when two or more roots of the auxiliary equation are equal, is this. Okay, so I hope that you have understood. So suppose I am considering a third order differential equation. And suppose the values of m obtained are all equal, m1 equal to m2 equal to m3. Okay, suppose all these are equal, then what will be the general solution? In that case, third order equation we are considering. So the auxiliary equation will have three roots, and here all the three roots are equal. Say it is equal to m. m1 equal to m2 equal to m3 is equal to, each one is equal to m. Then the general solution of such an equation will be y equal to c1 plus x into c2 plus x square into c3 e to the power mx. Then, so suppose we are considering a homogeneous linear differential equation of order n. And out of those n roots of the auxiliary equation, say k roots are equal, m1 equal to m2. Suppose I am considering nth order equation, I am not writing, and we obtained that m1 equal to m2 equal to m3 up to say mk, all are equal, each one is equal to m. And the remaining roots are, what are the remaining roots? M k plus 1, suffix k plus 1, m k plus 2, and up to m n. All these are real and distinct. Okay, real and distinct. And k roots are, these are the k roots which are equal, each one is equal to m. Then in such case, the general solution is the general solution of an nth order linear homogeneous differential equation having k roots equal and remaining n minus k roots are distinct and all real, is y equal to, I shall write c1 plus x c2 plus x square c3, this way you go on, then I shall get x to the power k minus 1 ck multiplied by e to the power m x, each one is equal to m, plus say ck plus 1 e to the power mk plus 1 x, ck plus 2 e to the power mk plus 2 x up to cn e to the power mn x. Okay, and here you don't forget to mention what are these c1 c2 up to cn, where c1 c2 to cn are arbitrary Then so we have a theorem. Actually, I already told that. I already told that. So let me state the theorem. Then it will be better for you. Let me state the theorem. Theorem. So it is 4.1. Number 1. Consider the nth order homogeneous linear differential equation a naught x yn plus a1x. But you remember all those a naught, a1, a2 up to an are real constants. They are not functions of x. Okay. This is 4.23. So consider this equation. Now if the auxiliary equation, I'm writing in short as AE. If the auxiliary equation of 4.23 has the real root m occurring k times, then the part of the general solution of 4.23. But what is the auxiliary equation? We know. Let me write it if requires. Corresponding to this k-fold, k times repeated root is C1, I already wrote it, C1 plus C2x plus C3x square up to CK minus 1, CK x to the power k minus 1 multiplied by e to the power mx. So this is the part of general solution corresponding to the k-fold repeated root m. Okay. Number 2, if further the remaining roots of the auxiliary equation (4.24), okay, I did not write the auxiliary equation. Auxiliary equation was n naught m to the power n, a1 m to the power n minus 1 up to a n equal to 0. This is the auxiliary equation 4.24. Okay. So this is the auxiliary equation. If further the remaining roots of the auxiliary equation 4.24 are the distinct real numbers mk plus 1, mk plus 2 up to mn, then the general solution of the equation 4.23 is y equal to c1 plus c2x plus c3x square up to ck x to the power k minus 1 e to the power mx plus plus ck plus 1 e to the power mk plus 1x plus the last one is cn e to the power mn x. Number 3, if however any of the remaining roots are repeated, then the part of the general solution of 4.23 corresponding to each of these are the repeated roots are expressions similar to that corresponding to M in part 1. Then, so the method we have learned, and now let us consider some example so that we understand. Example 4.23. Find the general solution of y triple prime minus 4y double prime minus 3y prime plus 18y is equal to 0. First we have to write the auxiliary equation. So call this equation say 1. The auxiliary equation AUXILIRY auxiliary equation of equation 1 is m to the power 3 minus 4m square minus 3m plus 18 is equal to 0. Now if I put m equal to minus 2 on the left hand side, then I shall get that minus 8 minus 16, is it 2 to the 4 4 to the 16 minus plus, because minus into minus plus 6 plus 18. So how much do you get? 18 plus 6, it is 24. Then it is like 18 minus 6, so it is equal to 0. So we have seen that m equal to minus 2 is a root of the equation, means root of this equation, auxiliary equation 2. So let us factorize the left hand side. This will give that m square m plus 2, then comes minus 6m square, because this plus 2m square was not written in the equation 2, so I have to subtract it. So originally there was minus 4m square, and I have to subtract 2m square. All total there will be minus 6m square minus 3m plus 18 is equal to 0. And if you want, then you can divide the expression m cube minus 4m square minus 3m plus 18 by m plus 2. That also you can do. So that is up to you. How do you find the roots? Minus 6m, then sorry, m plus 2 minus 6m plus 2. So it is actually I am writing minus 12m minus 12m, but there was minus 3m, so I have to write plus 9m, so that their sum is minus 3m plus 18 is equal to 0. This will give m square into m plus 2 minus 6m, m plus 2 plus 9 into m plus 2 is equal to 0, which gives m plus 2 m square minus 6m plus 9 is equal to 0, and this will give m minus 3 square is equal to 0. So roots are, how many roots are there? 3 roots, because the degree of this equation was 3. The auxiliary equation was 3, is it? So we will get 3 roots. But out of those 3 roots, 2 are equal. Roots are m equal to minus 2, 3, 3. Okay. So the general solution is y equal to c1 e to the power 3x plus c2 x e to the power 3x plus c3 e to the power minus 2x. Or I may write it in this form: c1 into c2x e to the power 3x plus c3 e to the power minus 2x. Okay. Where you need to mention where c1, c2 and c3 are arbitrary constants. Arbitrary constants. One may write the solution in this way. One may write the solution in this form also. y equal to say c1 e to the power minus 2x plus c2 plus c3x e to the power 3x. Okay, both are correct. If someone writes this form, then also it is okay. If somebody writes this way, then also it is okay. Now take another one example. Example 4.2. Find the general solution of y. Your order of this equation is 4 minus 5y triple prime plus 6y double prime plus 4y prime minus 8y is equal to 0. So call this equation 1. So immediately I shall write the auxiliary equation. The auxiliary equation of 1 is, how will you write? Just replace y by m, and here order of differentiation of y with respect to x is 4. So I will put power 4 minus whatever is the coefficient, write it down. Then here I have seen y, replace it by m. Then here the order of differentiation of y with respect to x is 3. So I will put power 3. Just like that, 6m square plus 4m minus 8 equal to 0. Call this equation 2. And if I try, then I shall see that if I put m equal to 2 on the left hand side, then its value is 2 to the 4 to the 2 to the 4 to the 8 to the 16 minus 8 5s are 40 plus 24 plus 8 minus 8. So what is their sum? 16 plus 24, it is 40 minus 40, 8 minus 8. So it is 0. So we have seen that m equal to 2 is a root of this equation 2. So let us factorize the left hand side of this equation 2. So either you can divide m to the power 4 minus 5m cube plus 6m square plus 4m minus 8 by m minus 2, or you can proceed in this way also. This will imply m cube m minus 2. So m power 4 is written, minus 2m cube is written, but there was 5m cube, so I should put 3m cube plus 6m square plus 4m minus 8 equal to 0. This gives m cube m minus 2. Let me write this 3m cube, 3m square into m minus 2. So actually I am writing minus 2 minus 3m square means plus 6m square, which is there already there. Now take 4 common, then you will get this. So taking m minus 2 common, I will get m cube minus 3m square plus 4 is equal to 0. Also you see, if I put m equal to 2 here, then it is 8 minus 12 plus 4. Means m equal to 2 makes the value of m cube minus 3m square plus 4 0. So m equal to 2 is again a root of m cube minus 3m square plus 4. Means m minus 2 is a factor of m cube minus 3m square plus 4. So we shall factorize it. That's why what shall I do? M square m minus 2. So minus 2m square is already been written here. Minus 2m square. But there was minus 3m square. So I have to put minus m square plus 4. Okay. This will give m minus 2. Then I can write it as m square m minus 2 minus, this is minus of m square minus 4, which can be written as m plus 2 into m minus 2. Okay, this will give m minus 2 multiplied by m minus 2 m square minus m minus 2 equal to 0. Now consider the last factor on the left hand side. Split the middle term minus 1. You express minus 1 as the sum of two factors of 2, and definitely they are minus 2m plus m minus 2 is 0. So I shall get m minus 2, m minus 2, m minus 2 into m minus 1, m plus 1. Okay, m plus 1. So the roots are values of m are 2, 2, 2 minus 1. Therefore, the general solution, thus the general solution of equation 1 is y equal to c1 plus c2x plus c3x square, because 2 is appearing 3 times, threefold. 2 is a threefold repeated root. So accordingly, the part of the general solution will be this one, plus the remaining one is non-repeated, minus 1. So I shall put c4 e to the power minus x, where c1, c2, c3, c4 are arbitrary constants. So hope you have understood this topic. Thank you everyone.